all. Today we are going to study about colloids. So, colloids are particles in which their size lies between that of true solution and suspension. That is, their size lies in between 10 angstrom to 1000 angstrom. So, in a colloid, there are two parts. They are known as dispersion medium and dispersed phase. So mainly we can term colloids as salts, gels or emulsions, and based on the properties of true solution, suspension and colloidal solution, we can easily distinguish the properties of colloids. So here a table is given in which different properties are categorized by true solution, suspension and colloidal solution. We can see each one. First property is given as nature. So the true solution is a homogeneous mixture and a suspension is a heterogeneous mixture, and colloidal solution appears to be homogeneous but actually it is a heterogeneous mixture. And particle size, this is the main thing that define or that differentiate a colloidal solution from the other two. The particle size of a true solution is less than 10 angstrom or 10 raised to minus 9 angstrom or 1 nanometer. And for a suspension, their particle size is less than 100 nanometer. And for a colloid, their particle size lies in between 1 nanometer and 100 nanometer. And sedimentation property. A true solution will not settle down easily or will not settle down, and suspension will settle down on standing, and colloidal solution never settle down. And their diffusion properties. True solution will diffuse quickly, but in case of suspension, they are unable to diffuse, and in case of colloidal solution, they can diffuse slowly. And visibility nature. In a true solution, the particles are invisible, and in suspension, particles visible by naked eye or by microscope. And in a true solution, particles scatter light and can be observed under an ultra microscope. Then filterability. A true solution can easily pass through animal membrane and filter paper, but in case of suspension, it is unable to pass through animal membrane or filter paper. And in case of colloidal solution, it can't pass through, or it can pass through filter paper, but not pass through animal membrane. And the appearance. True solution is clear and transparent, but suspension is opaque, and in case of colloidal solution, it is translucent. And next we are moving to classification of colloids. So colloids can be classified into three types. The category or criteria in which the classification is based on are as follows. First classification is based on the physical state of dispersed phase and dispersion medium. So whether dispersed phase is solid or dispersion medium is liquid, we can classify the colloids into 8 types. And the next classification is based on the nature of interaction between dispersed phase and dispersion medium. And the last classification is based on the types of particles of the dispersed phase. And the classification based on physical state of dispersed phase and dispersion medium. On the basis of this criteria, colloids can be classified mainly into 8 types. The 8 types are given in the following table, and the dispersed phase is a solid and dispersion medium is also a solid. That type of colloids are known as solid sol. Examples are some colored stones and precious or gemstones. And if the dispersed phase is a solid and dispersion medium is a liquid, that type of colloids are known as sol. Examples are paints, cell fluids, etc. And if the dispersed phase is a solid and dispersion medium is a gas, That type of colloids are known as aerosol, and examples are smoke, dust. And if the dispersed phase is liquid, dispersion medium is solid, that type of colloids are known as gel. Examples are cheese, butter, jellies, etc. And if the dispersed phase is liquid and dispersion medium is also liquid, that type of colloids are known as emulsion. And examples are milk, hair cream. And if the dispersed phase is liquid and dispersion medium is a gas, that type of colloids are known as aerosol. And examples are fog, mist, cloud, etc. And if the dispersed phase is gas, dispersion medium is solid, that type of colloids are known as solid sol. The examples are pumice stone and foam rubber. And if the dispersed phase is gas and the dispersion medium is liquid, that type of colloids are known as foam. Examples are froth, whipped cream, soap, leather, etc. And the next classification is based on the nature of interaction between dispersed phase and dispersion medium. Based on this criteria, we can classify colloids into two types. They are lyophobic colloids and lyophilic colloids. Lyophobic colloids means solvent hating colloids. That is, when metals and their sulfides simply mixed with the dispersion medium, they don't form colloids. So, for the formation of colloids from sulfides, we have to stabilize, or we need stabilizing to preserve them, and they are irreversible. Examples are colloidal solutions of gold, silver, arsenic sulfide, etc. And the lyophilic colloids are solvent loving, and they can be directly formed by substances like gum, gelatin, rubber, etc. on mixing with a suitable liquid. And they are self-stabilizing and they are reversible. Examples are gums, gelatin, starch, etc. And the final classification is based on the type of particles of the dispersed phase. And based on this classification, we can classify colloids into three types. They are multimolecular colloids, macromolecular colloids, and associated colloids. Multimolecular colloids consist of aggregates of a large number of atoms or smaller molecules whose diameter is less than 1 nanometer. And in macromolecular colloids, the molecules have sizes and dimensions comparable to colloidal particles. For example, protein, starch, cellulose, etc. The associated colloids are particular colloids that they can behave as normal electrolytes at low concentrations, but they can show the properties of colloids at higher concentrations. So the formation of these associated colloids or aggregated particles are also known as micelles. The formation of micelles takes place only above a particular temperature, and that is known as Kraft temperature, and above a particular micelle concentration, and this is called critical micelle concentrations. The micelle formations are shown by soaps and detergents. Then classification based on the type of particles of the dispersed phase can be summarized into a following table. And in this table, the three categories are given. So for multimolecular colloids, they are formed by aggregation of large number of atoms or molecules with diameters less than 1 nanometer. And in macromolecular colloids formed by large sized molecules, and in associated colloids formed by aggregation of large number of ions in concentrated solution. And these multimolecular colloids are lyophilic in nature, but macromolecular colloids are lyophobic, and the associated colloids show both lyophilic and lyophobic nature. And the molecular mass of multimolecular colloids is intermediate, and macromolecular colloids have high molecular mass, and associated colloids also have high molecular mass. And in case of multimolecular colloids, they are held by weak van der Waals forces. But in case of micromolecular and associated colloids, the interactive force is strong van der Waals force of attraction. And these lyophobic and lyophilic colloids can be prepared by particular methods. And for the preparation of lyophobic salts, we can use several methods such as condensation methods, oxidation method, reduction, hydrolysis, double decomposition, and exchange of solvent. For the preparation of lyophobic salts, the methods are dispersion methods and mechanical disintegration. And these methods are known as peptization, electron disintegration, etc. And the purification of colloids. Colloids can be purified using different methods. The important methods are dialysis, electrodialysis, and ultrafiltration. In the case of dialysis, the colloidal particles are separated from the impurities by the diffusion through a porous membrane such as parchment or colloidal. And electrodialysis, this is a special type of dialysis process which is accelerated by the application of a potential difference across the membrane. So ions migrate faster than colloids. And in the last method, the colloidal particle is separated by the process of filtration using a special type of filter paper which is impregnated with gelatin or colloidon followed by hardening in formaldehyde.